Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to discuss about the motion under variable acceleration. Now here, the terms were discussed in previous sessions. What is acceleration? The acceleration is divided into two types. One is uniform acceleration. Another one is variable acceleration. Here, the uniform acceleration comes under the magnitude of the velocity remains same in the equal intervals of time. Whereas for variable acceleration, the change of the magnitude of the velocity is not equal with the equal intervals of time. That's why here it is known as the variable acceleration. The acceleration is nothing but rate of change of velocity. That means change of the velocity with respect to its surroundings is known as acceleration. And now the things which we are going to consider in this session is the motion of a body under variable acceleration. Now further, the velocity and acceleration at any instant we are going to consider, where P is the position of the body or position of the particle or position of the body, and it is moving from O to X in the direction of the X, that is in OX direction. Now at any instant, the position of the body is the P. Now hit the P position. Let us think, there are some of the things which we have to know it. The things are here that the variables, that is S, is the distance traveled by the body, and T is the time taken by the body in seconds to travel the distance, where V is the final velocity and U is the initial velocity, and finally A is acceleration of the body. Here the body is moving on the earth. It is not going against to the earth. It is not moving upwards. Under variable acceleration, we are going to be considering here when body moves in horizontally on the plane, on the land, on the ground. When it moves upwards, again acceleration due to gravity comes into the picture. Now the velocity of the body is a rate of change of the displacement or rate of change of its position. The mathematically it is defined as V equal to ds by dt, where ds is the change of displacement, dt is with respect to time. The ds by dt is known as V equal to ds by dt. Coming to acceleration of the body, what is acceleration of the body? By differentiating this velocity equation with respect to time, then we'll get it is the acceleration of the body. So the acceleration of the body is the rate of change of its velocity. The rate of change of velocity, that is a dv by dt, that is known as acceleration. The d by dt times what is the v? ds by dt. Then it becomes d square s by dt square. Acceleration A equal to d square s by dt square. Now d square s by dt square, and also one more term that is also known as a dv by dt, then it can be simplified as v times dv by ds. Okay, v times acceleration A equal to v times dv by ds. That is also there. There are the three things: d square s by dt square, dv by dt, and one more thing is v times dv by ds. That is a mathematically in different forms. Now methods for velocity, acceleration, displacement from a mathematical equation. There are two methods are there. One is differentiations, another one is integration. As we mentioned here, the differentiation d by dt, ds by dt, that is a differentiation. The differentiation of the velocity with respect to time, that is known as acceleration. The methodology we expressed here, that is differentiation. But by integration, if you want to do it, how to make it? So if the acceleration was given, if you integrate the acceleration, equation of acceleration, then what will happen? Velocity. If we integrate the equation of, if we integrate the velocity equation, that integration gives the displacement, but with the constant of integrations which come into the picture. Okay, now let us, these are the equations. Suppose we are going to do it here, velocity and acceleration by differentiation. So suppose the equation of motion in terms of a displacement and a time, that is S equal to 3tq plus 2t square plus 6t plus 4. This is example if we consider. Now what is this here? Another equation is S equal to, there are three equations are mentioned here. 6 plus S equal to distance traveled by the body, 6 plus equal to 6 plus yt square plus 6t cube. Another one is 2t cube plus 40 minus 15. These are the various equations. If you want to obtain by differentiating this displacement equation, the velocity equations can be obtained. So differentiate the first equation, ds by dt, then 3 into 3, that is 9t square plus 40 plus 6. By differentiating your second equation, 6 plus 10t plus 18t square. 6 is becomes 0 here. Yeah. 10t plus 18t square. Then differentiating the third equation, that is 6t square plus 4. Okay. Next. Here, the way differentiated here, one more thing is that these are the velocity equations. If you, these are the velocity equation, v equal to ds by dt, v1, v2, v3, suppose. Now, if you differentiate these velocity equations with respect to time, the accelerations will be obtained a1, a2 and a3. Yes, let us differentiate with velocity equation. First v1 equation, then what happens? 18t plus 4. Again 10 plus 36t. The third equation, differentiate with respect to time, 12t plus 12t, not plus. Okay. So thus we can use the differential here. It is variable with the time. That's why it is known as the variable function, variable acceleration. Okay, with equal intervals of time, the magnitudes of the velocity changing is varying. It is not equal. That's why it is motion under variable acceleration. Okay, let us apply those things into the problem here. A particle starting from rest moves in a straight line whose equation of motion is given by S equal to t cube minus 2t square plus 3. Find the velocity and acceleration of the particle after 2 seconds. Find the velocity and acceleration of the particle after 5 seconds. So the equation of displacement, the equation of motion, that is S equal to t cube minus 2t square plus 3. What to do? Very simple. You have to differentiate this equation of S with respect to time, that gives the velocity. In the place of after getting that equation, substitute t equal to 5 seconds. We'll get the velocity after 5 seconds. And again differentiate the velocity equation with respect to time. And substitute t equal to 5 seconds in that equation. Then you'll get acceleration after 5 seconds. That's all. They're very simple. Now differentiate this equation of displacement. One time differentiation. That means that is 3t square minus 4t. Substitute t equal to, what is the 5 seconds? T equal to 5. Then 3 into 5 square minus 4 times 5. Here if you substitute 3 into t equal to 5. 5 square minus 4 times 5. Then it happens, what is that? 55 meter per second. Velocity after 5 seconds, that is 55 meter per second. Velocity after 6 seconds, again it will be changed. Velocity after 7 seconds, it will be changed. Velocity after 10 seconds, yes, again, depends upon the time, function of the time. That's why it is a variable. Now, acceleration after 5 seconds. Now, what is the velocity equation? That is 3t square minus 4t. Velocity v equal to 3t square minus 4t. If you differentiate this equation, again, one more differentiation. If you differentiate the velocity equation with respect to time, the acceleration equation will be obtained. What is the acceleration equation? A equal to 6t minus 4. This is acceleration. Here in this equation, the place of t, substitute t equal to 5 seconds. We will get it. Acceleration after 5 seconds. That is 6 into 5 minus 4. 6 5 is 30, 30 minus 4, 26. That's 26 meter per second square. If t equal to 10, what will happen here? T equal to 10, acceleration a equal to 6 times 10 minus 4. If t equal to 1 second, what will happen? A equal to 6 times 1 minus 4. That is a 2 second, 2 meters per square second. If t equal to 2 seconds, then a equal to 6 times 2 minus 4. 12 minus 4, 8 meter per square second. Like that, it varies with the time. That's why these problems are under the consideration, under the category of variable acceleration. Okay. The next problem is that very simple, very easy, always differentiating. You know the concepts of differentiation. That's what. So these equations, if here all the equations are given, the displacement equations are mentioned. That's why you're using the differentiation. If in the problem acceleration equations are given, then what to do? Acceleration comes out, you have to descend back. Then you have to use integration. Okay. Differentiation opposite is integration. Integration is the, okay, what to do? Integration comes back, coming down, next step, going down. Now here, the displacement equation S equal to 12t plus 3t square minus 2t cube. Okay, let us read. The problem was given so that we can understand better. A car moves along a straight line. Again, it moves along a straight line. It is not moving vertically upwards or vertically downwards. It is moving on the ground. Okay, whose equation of motion is given by, that is S equal to 12t plus 3t square minus 2t cube. Where S is in meters, T is in time in seconds. Okay, we know already. Now calculate what? There are two objectives are given. In each objective, there are two sub-objectives are there. Let us begin with that. Now here, velocity and acceleration at start. What is the velocity and what is acceleration at the start? Okay, that is time t equal to 0. And the second objective is acceleration when the velocity is 0. First objective is at the start, time t equal to 0, velocity acceleration. And the second equation, the second objective is the acceleration when the velocity is 0. Now let us write down the equation of the displacement, that is S equal to 12t plus 12 times t plus 3 times t square minus 2 times cubic t. Okay, let us begin with first differentiation. Yes, that is the velocity. Velocity v equal to ds by dt. That is 12 plus 60 minus 60 square. Here in this equation, substitute t equal to 0. That is the starting point. Then velocity v equal to 12 meter per second. Then whatever acceleration, again you differentiate. Acceleration v equal to dv by dt. What is the dv by dt? That is d square s by dt square. That is what happens here. 6 times differentiated. That is 6 minus 12t. In this equation, again substitute t equal to 0. Here t equal to 0. Then what will happen? Then acceleration a equal to 6 meter per square second. Okay. And if t equal to 1, it changes. If t equal to 2, we can see the variable acceleration. That's why it comes under the category of, again, variable accelerations. Now, let us begin here. Velocity at a start, that is equation, that is ds by dt equal to 12 plus 60 minus 60 square. That is v equal to 12 plus 60 minus 60. Velocity at the start means what? Substitute t time t equal to 0, starting point. The velocity at the starting point at time t equal to 0, that is 12 meter per second initially. Then again, acceleration at start. What is the acceleration at start? Differentiating the velocity equation with respect to time dv by dt. That is 6 minus 12t. Substitute here time t equal to 0. Then it becomes 6 meter per square second. So velocity v equal to 12 meter per second. Acceleration equal to 6 meter per square second. At what? Time t equal to 0. At the starting position, velocity and acceleration. Alright. That is the first objective we cleared. Okay, next one, acceleration when the velocity is 0. What is the acceleration when the velocity is 0? Okay, so that means at which we need the time. What is the acceleration when the velocity is 0? Now here, That is 12 plus, equate the equation of velocity equal to 0. That is 12 plus 60 minus 60 square equal to 0. From that, calculate the time. The time is obtained as 2 seconds. At 2 seconds, velocity is 0. Okay. That means what will happen? It means the velocity of the car. What is that meaning? The velocity of the car after 2 seconds we want. What is it? It means the velocity of the car after 2 seconds will be 0. At that time, what is the acceleration? We got the time. Then we know the equation. The acceleration A equal to 6 minus 12t, where t equal to 2 seconds. That's 6 minus 24. That is negative 18 meter per second square second. What is that meaning here? That is negative value. That means retardation. The negative acceleration is known as retardation, whereas the positive acceleration is known as the positive acceleration only. Here it is negative. The retardation, it comes into after 2 seconds. Okay. What happened here? Where do become retardation coming to the 0. The next one is the equation of motion of a particle. Here again mentioned what? The equation in displacement equation. The equation of motion of a particle moving in a straight line is given by S equal to 18t plus 3t square minus 2t cube. Now, where S is in meters and t, S in meters, t in seconds. That is what mentioned here. Because after substituting time values, if t equal to 0, S equal to 0 meters. If t equal to 1, we can know it. If t equal to 2, t equal to 3, it is proportional to, it is depends upon the time value. That's why displacement also changes. Now, there are again 2 objectives are given here. Number 1, find the velocity and acceleration at start. Again at starting position. And the second objective is here the time when the particle reaches the maximum velocity, and the third objective is maximum velocity of the particle. We need a time for reaching the maximum velocity when the particle reaches maximum velocity, and also the third objective is the maximum velocity of the particle. So after getting the time, substitute in the velocity equation, we will get it the maximum velocity of the particle. Now let us begin with S equal to, what is the procedure to solve this problem? S equal to 18t plus 3t square minus 2t cube. Now, if you substitute here again, differentiate the displacement equation V equal to ds by dt, that is 18 plus 60 minus 6t square. Substitute t equal to 0, we'll get it velocity at the start. Then after that, acceleration equal to dv by dt. What is the dv by dt? D square s by dt square. So yeah, make it differentiation here. 6 minus 12t. Again, time t equal to 0, we'll get it how much? The value is, when time t equal to 0, it becomes 6 meter per square second. When time t equal to 0, here it is 18 meters per second. Though at the start, that's the first objective. Okay. Let us begin. As we completed here, the solution, let us see. Differentiating the equation with respect to time t. What is the equation here? That the equation here, it is 18t plus 3t square minus 18t plus 3t square minus 2t cube. That is the displacement equation. Now velocity V we obtained as 18 plus 60 minus 60 square. Now substitute here time t equal to 0. That is 18 meter per second. Velocity V equal to 18 meter per second. The next equation, at the time start, that's why time t equal to 0. Then again differentiating the velocity equation with respect to time t. Then that becomes 6 minus 12t. Now V equal to 6 minus 12t. Substitute over here. And then t equal to 0 at the start. The acceleration is 6 meter per square second. Okay. The second objective is the time when the particle reaches its maximum velocity. So for maximum velocity, let us differentiate the equation of velocity equal to 0. Then that becomes, when time t equal to 0, time goes to become 0, then it reaches the maximum velocity. So the differentiating of the equation of velocity, that means acceleration becomes 0. That means that equation is 6 minus 12t equal to 0. Then time comes, that is the 0.5 seconds. Why acceleration is 0? The change of the velocity is 0. Here, the very important concept. That means change of the velocity is 0 means the final velocity becomes 0. When final velocity changes, there is no changing velocity with respect to time. That's why it reaches the maximum height, the final velocity becomes 0. Momentarily, the body will be stable. It comes back. That's why it is the maximum height reaching. It's not upward direction I'm talking. It's the horizontal. So when final velocity, there is no change in velocity. That means the acceleration is 0. That's why here 6 minus 20 equal to 0. Thus we get it this time. The time when the particle reaches the maximum velocity, that is 0.5 seconds, it reaches the maximum velocity. Now the third objective depends upon the calculated value of the second objective. At this time t equal to 0.5 seconds, what is the maximum velocity? So you have to substitute t equal to 0.5 seconds in the equation of the velocity. We will get it. Alright. The maximum velocity, that v equal to 18 plus 60 minus 60 square. Substitute t equal to 0.5 seconds in the equation of the velocity. That is 18 plus 6 times 0.5 minus 6 times 0.5 square 0.5. Then it is 19.5 meter per second. This is the maximum velocity, whatever initial velocity. The initial velocity is 18 meter. Yeah, the velocity at which starting, that is 18 meter per second. Starting means at the time t equal to 0. V at a time t equal to 0. At a time t equal to 0, v equal to 18 meter per second. At a time t equal to 0.5, v becomes v maximum velocity, that is 19.5 meter per second. Okay. This is it. These are the objectives. And what is the time? This is the first objective. This time t equal to 0.5. Second object is the first. This is the second. And here it is the third objective, 19.5 meter per second. Okay. Now let us begin. So far we covered the methodology of velocity and displacement calculation by using differentiation. Now we are going to for second part by using integration. So what is going to be given? For integration, the motion of the particle is given, acceleration motion is going to be given, it's not displacement. In the case of the differentiation, the motion of the particle is in terms of displacement and time. Here by integration method, the velocity and displacement by integration, the motion of the particle is given in terms of acceleration and time t. Now A equal to t cube minus 3t square plus 5. That is what the motion of the particle is given. The velocity of the particle at a time t equal to 1 second, it is 6.25 meter per second. And the displacement is 8.8 meters. Calculate the displacement velocity at a time t equal to 2 seconds. Okay. And the equation of acceleration, A equal to what is the t cube minus 3t square plus 5. So that is rewriting this equation. What is that in terms of different? That is A equal to what? dv by dt equal to t cube minus 3t square plus 5. If you integrate this dv by dt, then dv equal to t cube minus 3t square plus 5 times dt. Integrate dv on both sides, it becomes v. Then what happens? T power 4 by 4 minus 3 t cube by 3 plus 5t plus c1. This c1 is the constant of integration for velocity. That's what here. T power 4 by 4 and v equal to what velocity at 2 seconds. Now t power 4 by 4 minus 3t cube by 3 plus 5t plus c1. Where c1 is the constant of integration. That constant of integration can be calculated by substituting the values of t1 and v equal to 6.25 in equation. If you substitute v equal to 6.25, that's what given here. T equal to 1 seconds time t, what is the velocity? 6.25. Substitute t equal to 1, 6.25, then c1 comes. 6.25 velocity v and t1 equal to, what is the t1 equal to 1 second? 1 by 4 minus 1 plus 5 plus c1. What is the c1 value? c1 equal to 2. Substitute back the c1 into this equation. We'll get the velocity of equation. There in that equation, substitute t equal to 2 seconds, then velocity at 2 seconds will be obtained. Now v equal to t power 4 minus t cube plus 5t plus 2. Now in this equation substitute t equal to 2, then velocity after 4 seconds will be obtained. This equation is known as the parametric equation or a generic equation, where whatever values the time you substitute, you will get the velocity for these conditions. Now substitute here t equal to 2, that is 2 power 4 by 4 minus 2 cube plus 5 times 2 plus 2 plus 2. Then what is the velocity at 2 seconds? That is 8 meter per second. Okay. Next, a displacement at 2 seconds. The displacement at 2 seconds, what is the velocity equation? The velocity equation equal to t power 4 by 4 minus t cube plus 5t plus 2. Now what is the ds equal to? Velocity equation. ds equal to t power 4 by 4 minus t cube plus 5t plus 2 times dt. Again you integrate. If you integrate the ds, it becomes s, but constant of integration, that is c2. T 1 by 4 times t power 4 integration, that is t power 5 by 4, t power 5 by 5, 5 times 4, 20, t power 5 by 20 minus t cube by, that means t power 4 by 4 plus 5t square by 2 plus 2t plus c2. This c2 will be obtained again. What is the condition? The condition, the displacement is 8.8 meters. At what time? T equal to 1 second. Again substitute t equal to 1 second, and displacement equation 8.8. In that equation, then constant of integration, that is c2, can be calculated. Yes, substitute here s and t equal to 1, s equal to, what is the value of the s here? S equal to 8.8 meters. S equal to 8.8, t equal to 1, then c2 will be obtained. That's what c2, t equal to 1, s equal to 8.8. Substitute in this equation, above equation, then c2 is obtained as 4.5. Substitute this c2 in this equation, that is the known as the parametric equation of the displacement. Again, what we need at what time? After, what is the equation? After 2 seconds again, displacement velocity at 2 seconds, no. After getting the c2, now this is the equation of generic equation. Now here, what to be substituted to get the time? What is the time here? The time t equal to 2 seconds. After 2 seconds, what is the displacement? That is 2 power 5 by 20 minus 2 power 4 by 4 plus 5, 2 plus 2 square by 2 plus 2 times 2 plus 4.5. That is 16.1 meters. S equal to 16.1 meters. Okay. These are the things we calculated here. What are the things? Let me summarize in glance. That the first onwards begin with, yes, here the velocity and equation for variable acceleration. We consider different displacement equations. The displacement equations here 1, 2, 3, s equal to 3t cube plus 2t square plus 6t plus 4, and we differentiate with respect to time the equation 1, that is known as velocity equation. If you differentiate the velocity equation, acceleration equation will be obtained. That is a equal to d square by 18t plus 4. This is one equation I am explaining. The second equation, second and third also. Now we applied those equations. Yes, there are two methods are there. What is the first method is that to solve the problems. One is method of differentiation and second method is method of integration. Okay, the first method is method of differentiation, second method is method of integration. So we use the first step, method of differentiation. In the method of differentiation, the equation of motion is given in terms of displacement and time. So if you differentiate displacement with respect to time, velocity. If you differentiate velocity with respect to time, acceleration. That's why it's the step ascending. Displacement, differentiate velocity, differentiate acceleration. Now whereas in integration, what has happened? We have to descend. Acceleration was given. Integrate the acceleration, we'll get the velocity. Integrate the velocity, we'll get the displacement. That's all. But you need the concepts of the differentiation and integration. These are the basic concepts. You don't need very depth. It's very simple. Now here, the displacement or velocity or acceleration are the functions of time. Okay. Now the function of time, that's why with respect to time you have to differentiate and substitute the time value. That's it, or you'll get whatever we want, velocity or acceleration. That's what it done. The first equation is s equal to t cube minus 2t square plus 3. Differentiate s equation of motion of s with respect to time. Substitute what is the time t equal to 5. Obtain at that time what is the velocity. And again differentiate the velocity equation with respect to time, you get it acceleration. Substitute the value of the time t equal to 5 seconds, we'll get the acceleration. So that means the velocity, acceleration, displacement are functions of time. That's why it is known as the variable motion. The second problem, the displacement equation is 12t plus 3t square minus tt cube. Again, at this time of start, that means time t equal to 0. What is the velocity? Okay, time t equal to 0, that means time t equal to 0. What is the displacement? Displacement equal to, what is the time t equal to 0? Displacement becomes 0. Okay, but velocity will be there. That means you are in, what is that? Velocity giving, no? That is the velocity. Now, similarly, at the time of start, the third problem, equation of motion is s equal to 18t plus 3t square minus 2t cube. Again, there were three objectives in the problem. Okay, then again, time of the particle reach the velocity. And again, now we are coming to the integration. In the integration, the equation of motion of the particle is acceleration and time. Then only you can integrate the acceleration, velocity, integrate the velocity. What will happen? Displacement. And again, we have to find out here, the difference is that here you have to find out the based on the conditions, we have to calculate the constant of integrations, C1 and C2 and C3 and so on. After calculating the constant of integration, substitute back in the equation of motion, then you will get it done where you have to substitute time values, then you will get it at that times, what is the velocity, what is the acceleration, what is the displacement. Yes? Okay. These are the things. And we solved here, these are the models. If you understand the concepts, you can solve any problem in examination. But thoroughly you have to watch, you have to understand it. What is the variable acceleration? Okay, this is the summary, and thus references are followed here. R.S. Kurmi by Engineering Mechanics by R.S. Kurmi, and Engineering Mechanics by Irving Shames, and Engineering Mechanics by R.C. Hibbeler, and also Vector Mechanics. And also for engineers, it is also related to engineering mechanics in the form of vectors, that is the Beer and Johnston. With this, we can wind up this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.